Hello and welcome to another episode of Turing Dev Talks. My name is Jose and I'll be your host for today. And I'm tuning in from Montreal, Canada. And today on the panel, we have our guest speaker, Fahad, which is stunning from India. So before we get started, I'd just like to introduce him a little bit. So Fahad is very expert in cloud native, okay, to build cloud native applications. And also he has experience with a lot of technologies, and I'm going to list a few ones. So he is expert in Java, .NET, React Native, Node.Js, React.Js, and this is just a few ones, okay? And today he will help us to understand how to build cloud native applications, okay? And also the concept of cloud-based applications. So let's get started. And so, hi Fahad. First of all, thank you for joining this section today. And I'm so excited to hear from you what kind of applications we can build with these concepts. And so how are you doing? And how is the weather in India so far?
Hi, Jose, and thanks for giving the introduction, and thanks for having me today in the Turing Dev Talks. I would also welcome all the viewers here. Hi, hello everyone. Today is in India we have summer starting, so it's slowly we are getting up to the temperature rising, and today we're going to talk about cloud native applications. How do we build applications that would be, built for the cloud, not just saying this application runs on the cloud. And we will talk about the architecture, design, and patterns and things like that.
I'm pretty much sure that to be awesome. Okay, so let's kickstart this. But before we go to the questions, so I'd like to ask you, how is your day-to-day activity? So how is work for Turing remote in India?
Yeah, I absolutely love working for Turing. I mean, it's one of the most smoothest way to work with remote companies, working remotely. There's no hassle of setting up your accounts and discussing with the customers. It's like Turing is a backbone thing. We never really see them, and we are focused on our work, and all the things happen in the background, which is pretty smooth. I mean, I would say that's like working in a regular company, and for foreseeable future, this is how things will be for other companies as well. So that's good.
I think that's the future.
Yeah, that's the future. Yes.
Yeah. So the next 5 years, the number of remote position will increase a lot. I have these numbers. I don't want to share this number right now, but it will increase a lot, right?
Yeah.
All right. So let's kickstart this, and I'd like you to help me because I don't know anything. Okay, I'd like you to help me and our audience to understand what's the term cloud-based means.
Yes. So before we just go into the definition of cloud native, I would just talk a bit on how do you design systems. So at the end of the day, whatever you call cloud-based, cloud native, or monolith applications, it's basically the design patterns you apply to solve a particular problem. Like 10 years ago, the term cloud native was not there, but of course cloud was there, but nobody was building with which would be using the cloud resources in its right measure and compute and speed and all that. But now we are reaching a place where when we are developing products, we have to think about scalability. We have to think about how to handle the failures, how to have security built. That way, the developers are still doing their jobs, but the architecture takes care of these things and infrastructure takes care of these things. You either hand it off to Amazon, Google, or Microsoft, or you do it yourself, whatever it means for everyone out there. But definitely it has changed, right? So it's not just building this. Now what the good guys at CNCF, which is Cloud Native Computing Foundation, these guys have put together an approach of building and running applications in a way that is using the cloud resources more and more, and in the most optimized way, most secure way, most, all those things that you want to do, and you don't want to do as well. and let the cloud take care of some things, and you focus on your application, things like that. So this is where this approach is coming as a whole. And there is no set definition of an architecture. For you, the cloud native might be a different term. For me, it might be different. For some other, it might be just serverless. There are different paradigms, but then it's a pattern. At the end of the day, what you do, if I look at it, I am more a design pattern guy. When I always think of systems, I always think in two things. Either it is stateless applications or stateful applications. And how do you make this really stateless, and how do you make really stateful and make it scalable? And that's where the crux is now. All the other things around it is just the approaches, basically.
Yeah, so
that's how I would say.
Yeah, this sounds very interesting. Okay, and I have a few personal questions about this. One is about cost. Okay, what is about cost? If you go for a cloud native application and use cloud for everything, or if you use your internal infrastructure, okay, to build your server. In terms of cost, who is the best one?
Yes. So again, it would result in the type of product you're building. Let's take one simple SaaS application. Like you're building, let's say, an employee management system, or
a small application.
A small, but it's a SaaS application.
Okay, good.
Okay, so you're a product company. You're building a SaaS, and then you're hosting it on the cloud. And then, or you're hosting it on-premise. So there's this question, because you could, at the end of the day, you apply cloud native things to both. It doesn't matter, right? So when you start as a company, of course, your customers would be less, maybe focused around your marketing area and your country and things like that. But as you grow, then now you have to scale up. Now, do you want now? So when it's all about the scalability at this point, right? So when you scale, you have all the things that is working for you might fail for you, and that's the full vision. So you would have to take a decision that which is best for you. Let's say there's another scenario. If you could take, for example, you work with enterprises, and they would say, I need my data applications residing on my on-premise system, but maybe offload analytics or offload something which is outside the system, but the data, the employee data or whatever customer data, I need it in my new system. So, all these combinations that you would have to think of, and then the cost comes in. So cost, I would always do it at the end when we have to compare, but you would have to think through the scenarios that you would reach, and that's in your roadmap.
Especially talking about scalability, right? So let's suppose you have an infrastructure, your internal infrastructure to support your website, for example, but then you have a boom, website, and then you have to scale up your servers. So how would you do that quickly? I mean, that's the big challenge, right?
That's the question.
I'll let you guys decide which one is the better one. But if you ask me, I would go for cloud for sure. All right, so okay, could you help me to understand? Okay, which skills are needed for one guy be like you, expert in cloud native application?
Okay, I would just classify that into 2 or 3 sections to understand more. So today, in all of these, in all the major cloud providers, Amazon, Google, or Microsoft, there are a platform as a service which will help you build applications. Okay, so in AWS you have Beanstalk, or you have Fargate, which is a serverless version of the containers, and then you have similarly in Google, you have similar in Azure as well, Azure App Platform, Google Cloud Runs, and products like that. So let's say if you're just a very small 2-developer company, like very small, you're just creating, you have an idea you want to start off with, and then you're building your application. So so you need to you need to think in a way that you can deploy this application as let's say a container or an application package. Okay, all the cloud providers do provide container support. So my suggestion would be go with the containers. So when you go in the future and you have a bigger team, you can scale accordingly with different services. And all these app platforms give you all the things that you need, which is cloud native for you. Like you have logging, you have monitoring, you have automatic restarts, you have fault tolerant systems, you have CI/CD built in. Like you make a push, automatically picks up from your GitHub account, compiles and deploys a new version. So as a developer, you don't need to focus on these things. Now, once you go to the next level, you have 10 microservices to deal with, and each services is getting deployed in a different set of time. And now you need to control the resources within its own network, because there's security aspects, there is service to service communications, there is a lot of intercommunication happening, all this stuff. Then you go a little bit detailed, and you would need skills like Kubernetes, you would need skills like ECS or container services in all these different platforms. You could still use the PaaS services, but then my think from my experience, as you build and grow your microservices, it's easy this way to manage rather than exposing everything to the cloud. The one thing, when you use this platform as a service, you get as just an endpoint which is exposed to the public. Like you don't get a private network where everything's running. So
also it will increase the security of your application.
Yeah, exactly. You always have to keep thinking about security.
Yeah, makes sense. And so I think it would be good to understand a little bit more about cloud computing as well. Okay.
Yes.
So could you please elaborate a little bit more, okay, and help us to understand the main concepts of cloud native, or how this ecosystem works? And also, can we deploy anything in the cloud? For example, I have a static website, or I have a server-side rendering website, or I want to go for a microservice application there, a monolith application. So can we deploy everything to there?
Yes. So first, maybe the first question that you said about, just quickly explaining about cloud computing. So cloud computing, if you look at the definition, is basically an on-demand availability of your resources, which is your compute, your network, and your storage. And without anybody intervening and going and setting up the stack for you, there is just point click, you configure your network, you configure storage, and you configure your compute, and you deploy. Now, there are three major environments or computing systems that you could say. First is the infrastructure as a service, which is all these big companies are doing, which is IaaS. And then you have platform as a service, which is the next level, where all these, in a PaaS, you have packaged services. For example, your database as a service, or your application as a service, or like the example which I gave with Beanstalk and App Engines, things like that. So you have all these packaged as a platform, and then you only go and consume them in your application. Then there is software as a service, where you're building a software using PaaS or IaaS as you go forward with. And now the next level of computing that has started is serverless, which is function as a service. So here you only define your functions, and you have an endpoint getting exposed in either the API gateway, or you expose it directly into different cloud platforms give it in different ways. And this is something that it's a new thing that has come up in the last 5 years, and people are moving towards that. So serverless in a way is cloud native, because it covers all the things that we just spoke about: your scalability, your fault tolerance, your security, and supporting all these containers and all that stuff. So it is doing that. Okay, so now coming to the second question, how do you build completely end-to-end using cloud native design?
Yes.
So we have certain patterns that is being recommended as CNCF recommends or anybody else recommends, but it can be its own for you as well. So one is you build your applications in containers. So I would say Docker is pretty famous in the last decade, and people have adopted Docker in a way. Even now, from my experience, people, even though they don't know they're using cloud native, they would have built an application in container and go on in and deploy it as containers. Okay, they might not know there are some more things to it. If you add it up, then you are there to reach the scalability and all those things with respect to cloud native. So you would define container, you would define a load balancer which talks to a container and is exposed to the public internet, and then you have the security and networking stuff set up with either AWS or Google or whatever. So this is one side of it where you build your services with containers. The second is you have serverless. So you could just go and create your functions, your business functions, and deploy it in Amazon AWS Lambda or Google Cloud Functions or Azure Functions, and have an API gateway which is acting as a load balancer for you, and everything else is taken care again by the cloud provider. So these are two different architectures or paradigms that you can use to build cloud native applications today. And any of these bigger cloud providers have end-to-end support. You just go and have to, you just have to find the right services that you want to consume. Otherwise, you have all these things available today.
That's so cool, man. Yeah. And so in terms of jobs, okay, job opportunities, what are the job opportunities for one guy or one lady that would like to follow you and work with this kind of architecture?
Yes. Okay. So we do have backend engineers and people knowing Node.Js, Java, or .NET or whatever, all the major frameworks that we know. With respect to the next 10 years that would be on these technologies with cloud native, because more and work is becoming more remote, work is becoming more scalable. You have to be global. You cannot be just within the country nowadays. And thinking of that scale, you would need some sort of understanding of your infrastructure. So if a developer knows how the infrastructure would respond to for your applications, then that's next level for you. And now things are becoming more abstract. With Kubernetes coming into the picture, now you don't even need to go and know what is happening when you say, define me a network with IP addresses 192.168.0016 to this much. You don't even need to know that now. Yeah, you don't even need to know that now, because Kubernetes is giving you a declarative way to define your network, your compute, your storage, and everything. So it's becoming more abstract, and developers with a little bit of skill could also define their own infrastructure, and that's going to be becoming
nice. Every time that I need to build this architecture, I go for Dockers, containers, I go with AWS Fargate, and then that's magic. The magic happens. I just upload the container, set auto scalable, and then that's all. But that's so cool, man. Yeah. And so if you guys are looking for job opportunities, you can go to turing.com/jobs. Okay, you can search for the skill it's suitable for your tech stack, and you have tons of jobs there. You just select one, apply. If you are not registered at Turing, just sign up and then pass through the vetting process, and then I'm pretty much sure that you will find the job that you are looking for and work remotely. So working remotely for me, it's like it changed my life. Okay, now I can take my kids to school, I can pick up from the school, and I'm more present with them. You know what I mean? Okay, now Fahad, you mentioned before that you are expert in building microservice application, right? And I'd like to ask you to help us to understand what microservices are and how important are they in cloud native ecosystem.
Yeah. I think first, to define microservice, it's a type of service-oriented model where every capability of the application is split in a distinct self-contained service. So what I mean by that is, let's take the e-commerce scenario, right? So you have a basic functionality that you would need for e-commerce is you have an order service, you have a cart service, and a product service, right? So one to get the products, and then you have a carting service which allows you to manage a cart, and then finally the order service which deals with the payments, for example. Okay, so so when in microservices you create these 3 different services as individual contained services, which does the job of carting or ordering of products management, basically. So just focusing on that and exposing APIs with respect to that, right? So it's a microservice. So you get from the name. It's a service, but it's micro. But then it's over a period of time, from my experience and from what I've also read, and the typical problems that you bring in with different paradigms that you work with anyway. So it's an organizational change, first of all, and if you don't strategize your migration path or your architecture properly, you would end up doing a lot of backlog work or backburn that could happen just doing for a small thing. And you might even get complaints from the developers saying, I could have done this in 1 day, but then it took me 1 week just because you enforced me to do it this way, right? So
makes sense.
Yeah. So it's you need to have a strategy, first of all, as an organization, and then you should not be decomposing too much. So there is actually a book by there's a book on creating services based on domains called Domain-Driven Design, which I've also put in my comments.
We can put it into the description section.
Yeah.
The link for that.
Yeah, this is written by Eric Evans. This is like when the service-oriented model started, and then this guy has written an awesome book. I would really recommend everyone to read this. So basically, what you do is you group the services based on domains, rather than just thinking, okay, this is a unit, now create a service for this. You don't go very hardbound to it, but rather create it based on the domain. A domain in different contexts would mean for different people different things.
Yeah, that's something that I would like you to explain for us. What's domain-driven design?
Yes. So domain, as I said, it's different meaning for different people. Like for me, let's say that when you have a very technical thing, let's say you're working on an infrastructure, that's a domain for me from an IT support perspective. And now from a business point of view, a domain is something which is a bunch of functions for a given business, basically. Let's say we talked about the e-commerce scenario, right? So e-commerce, so the whole thing what I said about order and carts is a domain, basically, because you have somebody going to a cart would either buy your product or you will not buy a product. Okay, now do you want to split a cart service separately and an order payment service separately, and then manage the whole infrastructure problem around it? Or would you just want to merge them and just focus on the domain now? The whole ordering and carting is taken care of by one service, but then you get the benefit of the maintenance work that you have, you evade it, but then you still are working on a microservice model, but then based on domains, not based on the definition of microservice, because it's too confusing. I mean, people say microservice.
Yes, it's very confusing, and
it's
also
very confusing.
I think they are very confused about microservices and serverless applications. So can you brief about serverless too? Then we can clarify them.
Yes, okay. So serverless for me is in recent times, at least, the definitions have become more clearer. When serverless started, of course, I was too excited, and I ended up doing all my applications in serverless. And then I found the problems coming in, like the services were slow. I had to deploy 50 functions separately and managing all that. Then you have an API gateway. Some functions take more than 5 minutes, and then you hit the limit. All sorts of problems that you would encounter, and that's a limitation, right? So When you move to serverless, your thinking changes. You cannot regularly write function, you call a database, you call analytics service, you call this and that, and then finish your work. You cannot think like that. You have to think with the timeouts that would come in, all the problems in that. But now the definitions of creating a serverless applications is becoming more clearer. For me, if I look at from an architecture perspective, I would keep serverless for all event-driven applications. For example, you upload a file, okay? And you would have to do, let's say, resize the image. So customers keep taking photos in your application. They populate your storage, consume 1 GB in a day's time because all these 14 megapixel cameras and 30 megapixel cameras.
I know what you mean. Yeah, for sure.
Yeah, create huge files,
videos. Right? Yeah, huge
videos.
Yeah. Pictures,
yeah. So now you have an event whenever a file is uploaded to this folder or this bucket. You immediately run a background service which would resize the image, keeping the quality, let's say 80%, 70%, whatever, and then upload it back and resize it to different sizes. So people were seeing it in different machines, different laptops, or different screen sizes. It adapts accordingly. So this is an example of event-driven system. So likewise, you have to think where you could bring event-driven design into your applications. Serverless would be really an easy way. Of course, I wouldn't say long-running bad jobs as event-driven things, because then you have to think in a different way. Yeah. But at least the processes that could fit in the serverless model, which with the time constraint always in your mind, and if you can measure your event in terms of time and the logic that you would execute wouldn't take so much time, then you could design it. And of course, smaller APIs, just CRUD operations, creating, read, update, delete, of course you could do it, but then it's a bit too much to do everything in serverless. It's a balance that you have to take.
Yeah, it makes sense.
That would be the difference.
That's awesome. That's so cool. And today we've learned so much with you. So we learned about microservices, domain-driven design, event-driven design. What are serverless applications? So I think if you have any question related to those topics, you can reach out at us at Turing, okay, support@turing.com. And if there are any questions related to any subjects, you can raise your ticket there. Okay, email us. We have a dedicated team to reply that. They usually reply in the same day. Okay. All right. So if there are any questions that if there are anything that we didn't explain today, you can raise a ticket there, and maybe we can reply to you. But we talk about event-driven design, serverless application, cloud native, microservices. But why or how Kubernetes comes in? What Kubernetes is used for that environment?
Yes. So Kubernetes is an open source platform built by Google. They did it, I think, like a decade ago or close to a decade ago. And Kubernetes is basically, it's a container orchestration platform. It just started with that. Like there was this container orchestration by Docker, and then Google released Kubernetes. So it's just basically whoever is running applications in containers, they face regular problems like how do you maintain your containers, how do you upgrade versions, how do you give storage to the containers and things like that. It started with that as the main goal initially, but then it grew and became more advanced now. And now we see Kubernetes as an abstraction to the cloud, because all the big cloud providers are offering cross-cloud Kubernetes environments. So AWS has EKS, which runs EKS anywhere, runs on all the clouds. Google has Anthos, and similarly Azure has similar to that. So you have this, your code is portable, right? So you could write and create a container. You wouldn't have to worry about how it runs in different clouds, especially for product companies. You might be running some services which might be good in Google, some might be in Amazon, some might be in Azure. You might be using all these different services.
Makes sense.
So you could have one platform to manage all these containers running in different clouds. That's one big advantage. Then you have code portability, then the abstraction, as we were also discussing about jobs, that point came in, right? So as a developer now, if you know a little bit more about infrastructure, then you are, you're building application much more closer to run in the cloud, and
Makes sense.
it's
Totally
good in
agree.
that way.
Totally agree too. And if they want to start with Kubernetes, what is the best place for them to start learning?
Yes. So in Kubernetes has a free course in EDX. So I put a link in the description as well. So Kubernetes.io/training. You could get your hands dirty on understanding how Kubernetes works. There is a lot of open source thing how to set up in a desktop. Yesterday I was just reading that Rancher, which is a SUSE based company. They have launched a desktop thing. And
to manage that, like a dashboard or something.
Like a dashboard with just like how Docker desktop is there. Likewise, they have done a Kubernetes desktop. So people are investing their efforts in making it much easier for developers. And for sure, I think anyone follow through the course should be able to set up.
I'm not that much expert in Kubernetes, but I use Docker for everything, and I use Docker dashboards to manage my containers. But I'm pretty much sure that I'm going to start learning Kubernetes after. All right, so that has been my pleasure to talk with you today. Okay, we are come to the end. So is there anything else that you want to share with our audience today? Anything?
Okay, thanks from my side as well. It was a pleasure to talk to you. I would say first think from an architecture perspective, like what is really valid for you. Do you really want to go microservices, or you want to do monolith, but you want to start small and then grow big? As you grow, then you change your stuff. I've also put a book on microservices anti-patterns. So this is something that I always do. I study anti-patterns along with design patterns. Anti-patterns is something that gives a real world view of the problems that people face, and then you can think how to overcome that. So this is a good book. The reference I put in the description, you can look at it. So knowing all these different patterns, then you are in a much clearer picture that you could decide on which is best for you. There might be a situation where you would want to use serverless. Please go ahead and use serverless. There might be a situation where you would want to create microservice with containers, with Kubernetes, non-Kubernetes, doesn't matter. So whichever fits for you, you have to decide and go, but always keep the architecture in mind that if you have to scale, don't start from zero on the day that you have to scale. Always start planning for it, and then when you hit scale, you increase the.
Makes total sense. Yeah. All right. So thanks for your advice. This is really amazing. Okay. And if you are looking for a job, you go, as I mentioned before, go to Turing websites. Okay, turing.com/jobs. Search for the tech stack that's more suitable for you. For example, if you want to architecture position, if you want lead position, if you want React position, Python position, just search for it and apply for a job and pass through the vetting process. And I'm pretty much sure that you'll get there. Okay, don't forget to subscribe to this channel. Give us the big fat thumbs up if you enjoyed this video, and if you want to learn a little bit more for this, leave a message at the comment section below. I read your comments and I usually reply them, and let's plan our next interview. Okay, thanks Fahad. Thanks for attending this meeting today. That was my pleasure to talk with you. I learned a lot today, and let's try to book another one to talk a little bit more about serverless applications and Kubernetes and everything. Sounds good?
Definitely.
All right, man. So
awesome. Thanks a lot, man. Thanks a lot.
As that said, thanks, sir, and I hope to see you again.